Okay, here are some worked examples on points of inflection for exercise 503. So the first question is, find the point of inflection on the curve y equals x cubed minus 2x squared plus x minus 1. Now the question implies there is a point of inflection, which there is. It's not always guaranteed there is one, but here there is. So we need to find where the second derivative is 0 first. So the first derivative is 3x squared minus 4x plus 1. The second derivative, 6x minus 4. And we want to know, where does that equal 0? That's our first indicator of a possible point of inflection. So add the 4, 6x equals 4, divide by the 6. I'll just simplify that to 2 on 3. So there's a possible point of inflection when x equals 2/3. So let's find out if it is a point of inflection. We must do what's called the second derivative test. So we set up a little table like I had on the previous video. We put our 2/3 in the middle. Now 2/3 is 0.6 recurring. So to the left of that, I'm going to put 0.6, and to the right of it, I'm going to put 0.7. Now, if I substitute 2/3 back into here, I do get 0. If I substitute 0.6 back into here, I get negative 0.4. The important thing is that it's negative. If I put 0.7 back into there, I get 0.2 into the second derivative. And that's positive. So we can see here, concavity has changed. Concavity changed. So that means it is a point of inflection. Now, it's really important that we must also find the y coordinate. So we need to substitute x back into the original equation. So y equals 2/3 cubed minus 2 times 2/3 squared plus 2/3 minus 1. If you put that all into your calculator, you get negative 25 on 27. So therefore, POI at 2/3, negative 25 on 27. As a second example, we've got find any points of inflection on that curve f of x equals x to the 4 plus x. So let's start by finding the second derivative. First derivative is 4x cubed plus 1. The second derivative, 3 times 4 is 12, 12x squared, the 1 becomes 0. We want to find where that's equal to 0. And clearly, divide by 12, we've still got 0. Square root, we've still got 0. It happens when x equals 0. Now, we need to check if the concavity's changed, so we do our second derivative test. 0 in the middle, second derivative, something a little bit to the left of 0, something a little bit to the right of 0. Now, it doesn't matter what you substitute into x squared, you're always going to get a positive number. The key here is that 12x squared is always positive. That's going to be positive. That's 0, and that's going to be positive. So what we see here is concavity has not changed. Concavity has not changed. It was the only possible point of inflection, but it's not one. So therefore, not a point of inflection. I'll actually show you the graph for this one. I've got Desmos up, so I'll just unlock my computer. So the graph looks like this. So our possible point of inflection was just here. At that point, the second derivative is 0. To the left of that, we can see it's concave up. It's like a happy parabola. To the right of it, it is still concave up. So concavity did not change. At that point, concavity briefly disappeared, but it has not changed. The actual name for that is an undulation point. You don't need to know the name undulation point, but I find it pretty interesting. That is an undulation point.